Walk down the automotive aisle of any parts store and you will see them. Row after row of shiny bottles promising to fix leaks, restore lost power, and rebuild worn engines. They sound incredible. Some of them are actively destroying engines right now. Most of those bottles are expensive scams. Some have been hit with lawsuits after engines failed by the thousands. Others use chemistry so destructive it turns your oil into sludge, eats bearings alive, and kills catalytic converters. And the worst part, they are still on shelves today, often under new names. Today I am breaking down 11 engine oil additives you should never put in your car. Then I am giving you the 5 that actually work, backed by real testing, trusted by professional mechanics, and in some cases approved by vehicle manufacturers. Before you pour anything into your oil, stay until the end. Number 11. Graphite-based additives. Graphite sounds slick. If it makes pencils glide across paper, why not use it in your engine? Here is the truth. Pouring graphite into your oil is like dumping pencil shavings directly into your crankcase. It does not stay suspended. It clumps, settles, and turns into gritty paste that blocks oil passages and starves components of lubrication. One teardown of a small block Ford running graphite additive for just a few months revealed the oil pan coated in thick black paste and lifters completely starved of oil. Graphite also traps heat once it cakes onto metal surfaces, concentrating it directly on your bearings instead of carrying it away. Graphite belongs in pencils, not your crankcase. Number 10. PTFE, Teflon-based additives. Teflon in engine oil sounds high-tech. The reality is you are pouring solid plastic into your crankcase. PTFE does not dissolve in oil. It clumps, settles, and turns into sticky white sludge that gums up bearings and clogs oil filters. Engines treated with PTFE additives have been torn down to reveal scored bearings, starved lifters, and blocked passages, all from a product sold as protection. Here is the kicker. DuPont, the company that invented Teflon, told additive manufacturers to stop using it in engine applications in the 1990s. When the inventor says it does not belong in your engine, that settles it. Teflon belongs on frying pans, not in your motor oil. Number 9. Stop leak additives. Stop leak additives work by using harsh chemicals to swell rubber seals. That slows the leak temporarily. Over time, the rubber becomes brittle, cracks apart, and leaks worse than before. Then those chemical compounds start circulating through the oil system, plugging filters, clogging lifters, and blocking passages modern engines depend on. A small valve cover leak needing a $40 gasket becomes a full engine rebuild because someone chose a bottle of stop leak instead. These products do not fix leaks. They delay them while creating far more expensive problems. Number 8. Magnetic oil additives. These products claim to magnetize your oil so it clings better to engine components. Oil is not magnetic. Crankshafts and bearings do not develop magnetic fields that attract oil molecules. What is actually inside these bottles is usually thickened oil loaded with metallic flakes designed to look impressive. One mechanic cut open the filter from a car using one of these products and found the filter media filled with tiny metallic particles. That was not protection. That was metal sludge grinding away at cam lobes and bearings. No API certification. No OEM approval. No real test data. Keep it off your shelf. Number 7. Compression restorers. These products are thick compounds loaded with soft metals like copper or tin that temporarily fill gaps and coat worn cylinder walls, bumping compression just enough to quiet a knock or reduce smoke briefly. They do not repair worn rings. They do not fix valves. One customer poured a compression restorer before a long road trip. 300 miles later, the engine seized. The additive had clogged the oil filter and cut off lubrication to the cylinder head. If compression is gone, parts are worn. The only fix is mechanical. Compression restorers do not buy time. They hide the problem until it becomes catastrophic failure. Number 6. Solvent-based flush additives. Most engine flush products contain kerosene, naphtha, or mineral spirits, essentially paint thinner for your crankcase. It strips deposits but also strips the protective film bearings and cam lobes depend on. One customer used a flush additive before an oil change and drove home. By the time he arrived, the engine was knocking badly. In turbocharged engines, the damage is immediate. turbos spinning at over 100,000 revolutions per minute rely on a pressurized oil film thousandths of an inch thick. Solvent-thinned oil destroys that film in minutes. If you want a cleaner engine, use quality oil and change it on schedule. Solvent flushes do not clean engines. They finish them off. If this is saving you from pouring something destructive into your engine, hit subscribe right now, because the next video covers 5 more products the automotive aftermarket sells that your vehicle manufacturer specifically warns against. Number 5. Excess ZDDP in modern engines. Zinc was essential for classic flat tappet camshaft engines. For modern engines with catalytic converters, it is actively destructive. When zinc burns off, it coats oxygen sensors and catalytic converter substrates with a glassy layer that chokes them permanently. A customer added 2 bottles of zinc booster to a modern truck, believing more was better. Within 2,000 miles, his check engine light was on and his catalytic converter was destroyed. A $1,200 mistake. Modern oils already contain precisely calibrated zinc levels designed around emission system limits. Adding more does not increase protection. It destroys components your engine depends on. Number 4. Chlorinated paraffin additives. Marketed as extreme pressure protection. What they actually contain is chlorinated paraffins that produce hydrochloric acid when heated inside a running engine. The same corrosive compound used industrially to strip rust from steel, circulating through your bearings and cam journals. One engine showed chemical pitting on main bearings and acid etching on cam lobes after just 2 oil changes with a chlorinated paraffin additive. Banned in multiple countries due to environmental toxicity. They do not belong in any engine regardless of what the label claims. Number 3. Cheap moly additives. Molybdenum disulfide is a real friction modifier when formulated correctly. The cheap versions are a different story. Quality moly keeps particles ultrafine and suspended so they bond evenly to metal surfaces. Budget moly contains clumpy, inconsistent powder that sinks to the bottom and cakes into paste. A BMW torn down after running generic moly additive had a filter plugged solid with black sludge, dangerously low oil pressure, and an oil pan full of material resembling tar. Modern engines run tighter tolerances than ever before. Powdered metal floating through those passages starves critical components and accelerates exactly the wear it was supposed to prevent. Number 2. Mystery oil conditioners. Bottles with vague names like oil conditioner and engine treatment promising smoother running and restored protection. Look closely and you will find one thing missing: any list of actual ingredients. If a manufacturer will not tell you what is inside the bottle, it is because the answer would end the sale immediately. Most mystery conditioners are thickeners, dyes, and chemical combinations that destabilize base oil chemistry without providing any real protection. A Dodge Ram came into a shop after months of using one of these products. Oil pressure had dropped. The engine was ticking. When the filter was opened, the oil had turned into molasses-like sludge. Real additives carry API certifications and published test data. Proprietary blend means one thing: they do not want you to know what is inside. Number 1. Fake nanotech suspensions. Companies label products with nano and promise microscopic particles that rebuild worn surfaces and eliminate friction. What most actually contain is ground metal powder suspended in oil. Pour it in and those particles circulate like liquid sandpaper, scratching bearings, clogging filters, and settling in oil passages. A mechanic cut open the filter from a turbocharged vehicle running one of these additives. The filter media was covered in metallic particles. The turbocharger failed within 2 weeks. Real nanotechnology requires years of research and strict particle size control. A $20 bottle with no published test data is not nanotechnology. It is expensive engine damage sold as innovation. Now, the 5 that actually work. Number 5. Lucas Heavy Duty Oil Stabilizer. A product mechanics have used since the 1980s for one specific honest reason. It slightly thickens worn oil to restore pressure and reduce noise in tired high-mileage engines. It does not rebuild engines. Used correctly in the right application, it genuinely helps overworked motors survive longer. Number 4. BG MOA Motor Oil Additive. A professional shop staple built on a balanced blend of detergents, dispersants, oxidation inhibitors, and anti-wear agents. It does one job: extending and strengthening the oil already in your engine. Mechanics have used it for decades because it consistently delivers in real engines under real conditions. Number 3. ARX Oil Treatment. Designed specifically to address stiction in hydraulic injector systems, particularly Ford Power-Stroke diesel engines. It cleans varnish deposits from injector components and restores smooth operation. Trusted by diesel fleet operators who cannot afford injector failures on working vehicles. Number 2. Liqui-Moly MOS2 Anti-Friction. The right moly additive done correctly. Ultrafine particles that stay suspended rather than settling into sludge. OEM approved in some European applications. Independent oil analysis consistently shows lower wear metal readings in engines running this product. It delivers what cheap moly products promise and fail to provide. Number 1. Tribotex Nano Additive. The one legitimate nanotechnology product in the market, developed from research funded by NASA and the US Department of Energy. Uses engineered ceramic nanoparticles that bond to metal surfaces under heat and pressure, filling microscopic surface imperfections and genuinely reducing friction over time. Not cheap, not instant, but backed by real data and real-world results that cheap alternatives cannot match. The takeaway is simple. Most bottles on that shelf are marketing dressed up as chemistry. The best protection starts with quality oil changed on schedule. Additives are the finishing touch, not the foundation. If this saved you from pouring something destructive into your engine, hit like and share it with one person about to add something to their oil. Subscribe and turn on notifications because we publish detailed, no-nonsense car care content every week. Drop a comment below telling us which additive you have been using. We read every single one.